Okay, for what we have for homework 3.3, okay, we have for the first problem, we're looking at rewriting as a logarithmic equation the statement where we have 6 to the negative 1 is equal to 1/6. Okay, and now just in taking what we have in this particular regard, okay, so we have taking the logarithm in the exponential base. So you have a base 6 logarithm of 6 to the negative 1 is equal to the base 6 logarithm of 1/6. And as the base a logarithm of a to the x is equal to x, guess what? A is represented by 6. So we have negative 1 is equal to the base 6 logarithm of 1/6. And in the format to what we have in terms of the blanks to fill in, so just taking the switch around. So you have the base 6 logarithm of 1/6 is equal to negative 1. So that would be the first answer. Now, for what we have in terms of writing as an exponential equation, here we have the base 4 logarithm of 64 is equal to 3. So I can eliminate the presence of base 4 logarithm if I take the exponential base that matches the logarithmic base. And here we have the base 4. So if I apply both sides as powers to which the number 4 is going to be raised, and we have a to the base a logarithm of x is equal to x. 4 to the base 4 logarithm of 64. Our x value is at 64. And here we have 64 is equal to 4 to the third. And we have, conversely, we had that 4 to the third is equal to 64. Now, for what we have in terms of rewriting a statement. Okay, so writing as a logarithmic equation, we have for the first part, we have e to the fourth is equal to x. And for what we have in terms of rewriting as a logarithmic equation, now we have the exponential base e to the fourth, and to take care of the exponential base e by applying the base e logarithm. And for what we have here, a base e logarithm of e to the fourth, that goes to 4. And we have the base e logarithm of x, okay, can also be written, and it will be rewritten as the natural logarithm of x. Okay, so you can say that 4 is equal to the natural logarithm of x. And if we have the natural logarithmic term, or the logarithmic term, period, on the left-hand side, we have ln of x is equal to 4. Now, in terms of rewriting as an exponential function, we have for part B, we have natural logarithm of 2 is equal to y. And if I take care of the natural logarithm, remember, natural logarithms are logarithms in base e. And if I take the exponential base e to take care of the base e logarithm, we can treat both sides as powers to which e is going to be raised. So we have e to the base e logarithm of 2 goes to 2. And we have is equal to e to the y. And again, we have conversely, we have e to the y is equal to 2. All right. Now, for what we have in the case of the third part, okay, if I write, okay, number 3, part A, as an exponential equation, okay, so we have the base 8 logarithm of 1/8 is equal to negative 1. So if I take care of the base 8 logarithm and treating both sides as powers to which the number 8 is going to be raised. Okay, so it's going to follow that for what we have here, we have left-hand side becomes 1/8. We have is equal to 8 to the negative 1. Okay, where you say we have 8 to the negative 1 is equal to 1/8. As for what we have for part B, if I rewrite as a logarithmic equation, okay, so the exponential base to a specified power we have in 3, and I can take care of the exponential base 3 by applying the base 3 logarithm. And so we have applying base 3 logarithms on both sides. Base 3 logarithm of 3 to the fourth Okay, it goes to 4. And we have is equal to the base 3 logarithm of 81. So we have the base 3 logarithm of 81 is equal to 4. Okay. Now, for what we have in the case problem number 4, so again, going from logarithmic to exponential. So we have natural logarithm of 6, natural logarithm, again, we have a base e logarithm. And if I treat both sides as powers to which the exponential base e will be raised, and here we have e to the base e logarithm of 6, where e to the natural logarithm of 6 goes to 6, and we have is equal to e to the y, or we can say e to the y is equal to 6. And for rewriting as a logarithmic equation, okay, here we have e to the x is equal to 8. And to take care of the exponential base e, we have base e logarithm of e to the x is equal to the base e logarithm of 8. And left hand side again goes to x. And we have is equal to the base e logarithm of 8. And again, the base e logarithm is a natural logarithm. So you have that x is equal to the natural logarithm of 8. And in terms of evaluating expressions, now we have for number 5, okay, we have in part A, we're looking at a base 6 logarithm of 6. And okay, now we have a match between the exponential and the logarithmic base. Okay, and since we don't have 6 to any raised power, you can say that's implicitly going to be the base 6 logarithm of 6 to the first. Exponential logarithmic bases cancel, and so that will go to the degree which we have here, which is 1. Now, for what we have in the case of the base 4 logarithm of 1/64th, I can write 1/64th in terms of the exponential base 4. Okay, right now I have 1/64th, and 64 is 4 to the third, but 1/64th is going to be the reciprocal of 4 to the third. And the reciprocal of 4 to the third, if I put it in direct fashion, and we have 1 over 4 cubed becomes 4 to the negative 3. So we have the base 4 logarithm of 4 to the negative 3. And we have with the exponential logarithmic basis going out, the result is at negative 3. And we have in the case of evaluating what we have for number 6, here we have a base 5 logarithm of 1/25th. And 25 is both a multiple and integer power of 5. And 25 is 5 squared. 1/25th will be the reciprocal of 5 squared. So here we have a base 5 logarithm of what's going to be 5 to the negative 2. And again, after the exponential and logarithmic bases cancel, okay, we end up at negative 2. And as for the last portion, we had the base 2 logarithm of 32. And 32 relative to 2 is both a multiple and raised power of 2. So we have 32, it becomes 2 to the 5th. And with the 2's going out, the result ends up at 5.